All right, let's take a look at this one. We're going to solve for y first. So that is step one. And then, our goal is for it to say y equals, and everything else is over here on the right side. So first thing I want to do is move the 6x. So I'm going to subtract 6x from both sides. I don't tend to put it underneath the constant, the number, because I don't want to ever think, oh, I need to subtract 15 minus 6, because those are not like terms. So I'm not going to stack them together. They need to stay separate, and I would put the x first because our goal is to get our slope-intercept form. That's why we're solving for y, so that we can have it in this form, so that graphing it is much less complicated. So that means I'm going to put the x value first and then the constant at the end. All right, so now I'm going to divide everything by 5 so that I just have my y equals. This line, so it's confusing. So I have negative 6 over 5x plus 15 divided by 5 is 3. All right, so that is step one, solve for y. Okay, you can graph the equation. So when I have it in slope-intercept form, I know that the number in front of x, which is called m, which is the slope, is negative 6 over 5. That's the rise over the run, if you've learned it that way. And then the y-intercept is b at the end, which is 3. And so we always begin with b. So if b is 3, and that's the y-intercept, that means it's on the y-axis at positive 3. So the y-axis, positive 3, so I'm going to put a point there. And then I'm going to use this rise over run. And since it's a negative, instead of rising, we're going to actually fall. So we're going to fall 6, 1, 2, 3, 4, 5, 6, and then run 5 to the right. And so, yep. If we had gone up 6, we would just then go left 5, and it would still create this nice linear graph. So I'm going to connect points as best as I can. Nice little straight line, and you want to extend it in both directions as closely as you can. You can put arrows on both ends to show that you understand that that line continues in both directions for infinity. All right, so we graph the equation. Use a graphing calculator to check your graph. Okay, so let's go over to, it's gonna show up here. Oh, it'll be okay. Let me type it in on this. 6x plus 5y equals 15. I'm going to type it in exactly the way that it was. But let's also, and notice, I mean, ours appears that it's different, doesn't it? But let's look at 2.5, 0. So this 0, 3. Okay, let me go back to this. 0, 3. At about 2.5, it's here at 0. So yeah, it appears to be the same. And we had y equals negative 6 over 5x plus 3. So let me type in that. Y equals negative 6 over 5. Use your little cursor to get out from under the fraction over x plus 3. And notice that the line is directly on top of the original line. Let me erase what we had from our drawing so that you can see just what's on the Desmos here. So let's see if I change that to 2, just so you can see the 2 different lines. Now, if I change it back to what it should be, it goes right on top of the original red line. So if it was a 1, it would be there. At 2, it's there, but at 3, it's right on top of it. That means that we've solved it correctly. You know, that these are equivalent equations. They have the same value. And so our solving was right. And then this matches what we did on the other one. All right. I hope that was helpful. See you next time.